because I know they're gonna watch it.
Yeah.
Because most of the time I just record it, I see 0 views on the YouTube video, and nobody has actually reaped any benefit from this. Anyway, so the idea is that you guys are learning about at the start of calculus. Okay, I'll give you guys a roadmap. So calculus, the first thing you learn about is derivative. Okay, just to get it into your brain, and it will make sense over time. But right now, I'll just sit there. Derivative is it gives you the gradient function. Like what is a gradient function? Okay, first, what is a gradient? So this in this one, I will explain like the first thing, which is everything about gradient. So what's the gradient? Gradient is like how steep something is, right? Okay, so to calculate gradient of a line is rise over run. The easiest way to calculate gradient is rise over run. Okay, so if you're starting at a point here, and then in the next 10 meters, it rises only 1 meter. Then the gradient is not that steep, right? So this hill has the gradient of rise over run 1 over 10, which is 0.1. Okay, you can walk that. Now imagine a different hill where in the next 10 meter, scale's not correct, but it rises 100 meter. Then what's the gradient here? 10. Yes, the gradient is 100 over 10, which is 10. This is a massive gradient.
You could walk up that though.
No, you
That's
could.
like Jacobi.
You can.
Jacobi's really steep.
It's really steep, yes.
Jacobi.
100 meters.
Well, not 100 meters, but it's probably got in the same scale.
Okay, let me give you guys a scale. Okay, normally for a road, for example, you're talking about the rise over run is about 1 point something. If you get 10, that's not walkable. 10 meters is like that, and 100 is like,
Yeah.
I don't think it's climbable. It's like a rock climbing thing.
That's got the same.
Oh wait. So
same scale.
every 1 meter you go 10 meters.
10 meters up, yes. So from here to here is 10 meters up. That's like a.
That's 100 meters.
That's
It's
so
really steep. You can't walk it. You have to climb it with like rock climbing. You can climb it, yes.
You said you could walk it.
I reckon.
no, I don't think you can. I'm pretty sure you can't walk that.
Yeah.
Okay, but anyway, so this is the idea of rise over run. Okay, then the main concept is the next concept is the tangent. So tangent is a line. Oh wow, I will talk about the tangent line. You know what? Remember I told you guys a tangent before is the line that does what?
It touches the unit circle at 1 point.
Yes. Now it touches a graph at 1 point.
Okay.
Okay. Now we're learning the general definition of it. So lines that touches the graph at 1 point.
This is not a tangent line then, Corey. This is
Nope, it's not. You're correct. It's not a tangent line. Calm down. I'm getting there. It touches the graph at 1 point. So if you have a graph that looks like that, right? The tangent line at a certain point looks something like this. Okay, that's a tangent line. Make sense?
Yes.
And the tangent line has a gradient because it has the rise over run thing, right? What's the how do you find? So if this one has the equation y equals to mx plus c, then m is the gradient.
We talk about
It's the rise over run.
In physics.
Yeah. Okay.
I just
In
know
physics as well.
Positive reaction rate, and then how much is the initial reaction rate? Because you go from here to here, and you go this gradient and down, and you go boom, boom.
Yes, that's right. Now I'll teach you guys the next concept that is a little bit more abstract. What does it mean by the gradient of the tangent line at the point A? Right? What does it mean? The gradient of tangent line, the concept here is called instantaneous rate of change. Instantaneous rate of change. I actually skip a chapter. Chapter 7 is when you learn about instantaneous rate of change. But surely you guys can get this one by itself.
Hopefully.
Instantaneous rate of change. Okay, what it's saying is that, for example, when you're driving on the road, right? Your speed is not always 60 kilometers per hour, right? It's like 60, 58, right? From this one side, your speed, this is your velocity, your speed, and this is the time, right? You could start at 60 on the road, and then you know when you're going downhill, you go past the speed limit a little bit. God forbid, shouldn't do that. But then after that, if oh my god, there's a car in front of me, you slow down a little bit and then you start going up again when it's like, and then you get to the highway, you have to ramp up to 100 and then you keep around 100, but it sort of fluctuates like that. You can't keep exactly 100. You know what I mean? So what I just drew is a graph, right? Now, what does it mean by instantaneous rate of change? It is, for example, let's say at that moment, that is 30 seconds into, or let's say 5 minutes into your trip. At exactly 5 minutes and 0 seconds, the graph is at this point. If you draw the tangent at this point, let's say if I draw the tangent line here, all right, the gradient tells you
what the instantaneous rate of change is.
Yes, what they, yeah.
Wouldn't you do it from
How your velocity is changing at that point, yeah?
Wouldn't you draw the line from the start of the 60 across like that way to the point?
To the point, no, that's the average rate of change. It's like from the beginning to that point, what's the total change in velocity? The total change in velocity. But this one is like, this one's actually the gradient will give you the rate of change of speed, right, over time, which is actually your acceleration.
True.
Does that make sense? So at that point, you are slowing
S
down.
equals a.
No, the notation is,
S
you
over
learn this
T.
later, ds over dt.
I don't know.
D means like the differential, so like the change in the
Isn't that
speed.
triangle?
Oh, triangle.
Let's say V. Let's go V. Yeah, it's that triangle thing. Yeah. Delta V over delta T. It's like that thing there. Delta V over delta T thing. But delta, yes. So dV over dt is actually the concept. That's what it means by the gradient of the tangent at that point.
I have to go because my dad's here.
Oh, right. Okay. That's all good then. Well, this is recorded, so
Alright.
you can watch it later. Okay. But yeah, you can listen while you're packing up. So yeah, so that's what the gradient. That's what the gradient is. It's the rate of change at that point in time.
But it's instantaneous.
Instantaneous, right? At that point in time.
Yeah.
Because later on, let's say 11 minutes later, if you draw another tangent line here, that's you're accelerating, right? The velocity is going up.
Is that an instantaneous one, or would your
Yeah.
instantaneous one be like further down? Because that's like as soon as it happens.
There's only one gradient, right? If you draw the tangent at that line, see you later, Blake.
Like,
Okay. So yeah, that's the instantaneous rate of change at like 11 minutes. So essentially, it's the acceleration, right? At 11 minutes, you're actually accelerating. Your velocity is going up.
yeah.
Okay, that's what it means by instantaneous rate of change. That's the meaning of the
Like, what it
gradient.
is at that exact point.
Yes, that's right. Yeah. Now, how do we actually find like the gradient of the line at that point? So you need to consider something because it's hard to find this line here. Trust me, it's hard to find this line until you know calculus. But right now it's a bit difficult to find this line. So I'm going to use the textbook example. Let's say we're given a graph that looks something like this. This is just a basic y equals x squared, yeah? Alright, y equals x squared graph, and then we're choosing a point 1, 1, comma 1. Now, in order to study what is the gradient of the tangent at that point, see ya. To study what is the gradient at that point, I will need to choose another point. Now, this point it differs like the x value. This is 1, right?
Yeah.
It differs by a certain h amount. Okay, this is 1 plus h. Okay, all right. So this point has the coordinate x is 1 plus h. What's the y coordinate? Can you figure this out? Hint, it has something to do with the equation. How do you find y if you give an x? You sub the x value into the x value.
1 plus h squared.
Does it make sense?
Yeah.
Yeah, it's just because y equals to x squared, right? And instead of x, you get 1 plus h, so it's just 1 plus h, everything squared. Okay, so that's the y coordinate of this point here. So yeah, so now we've got that point. Now let's consider.
Is this, when you're doing this, what are you trying to find with this? Like the gradient of the line? Like this?
Joining these two.
Oh, so if you get given 2 points, then you want to know. Okay.
Yeah, okay, so now we're looking at the gradient of this line. So what is the gradient of this line? We know rise over run,
Yeah.
right? Okay,
Would it
what's a
be-
rise?
Would it be like the difference between 1 and 1 plus h squared?
No, rise means 1 plus h squared minus the y value
Okay.
from the first point, right? Maybe I'll use blue for this. So it's 1 plus h everything squared. That's the y of the second point minus the y of the first point over the x of the second point minus the x of the first point.
Okay.
Does it make sense? It's just change in y minus change in x, right? Yeah. So now we've got this one. Then okay, this is the gradient, right? And see, note that what happens when the 2 points, when the h value gets closer to 0. Because remember, h is the difference between the first and the second point on the x-axis, right?
Yeah.
When it gets closer and closer, so imagine that point getting like here, and then getting like here, and then getting like here. What happens? That line will actually, it's hard to imagine, so I prepped something for you guys here. Very visual. Tell me if your teacher does this at school, because if they can, they're a really good teacher. I haven't seen many actually can do this. I'll show you in a second the explanation of how it looks like. So see, this is a setup, right? 1 plus h. This is a top point, 1 plus h, and yeah. So this is 1 plus h and 1 plus h squared, right? I'm just writing as f1 plus h, but basically it's just the y value of that point.
Yeah.
And then this one is the main point, and then we want to see what happens when this point moves closer and closer and closer to the other point. Okay? Because right now, does this look like a tangent? Does the black line look like a tangent at the point 1, 1? No, it's like it should look something like that. Correct, right? So you want the line that looks something like this as a tangent at 1, 1.
Yeah.
Because if you can find the tangent at 1, 1, the gradient of that is the instantaneous rate of change.
So that's what like happened. Yeah. That's
Yes, and I'll show you guys how that happens here. So prepare the h value. See, as h gets closer and closer, so the h decreases, right? It's like 1.41 now.
Yeah.
As it closer and closer to 0. So now what does the line look like? It looks just like the tangent line.
Yeah.
Does it make sense?
Uh-huh.
Okay, you see that again, right? So right now it's not tangent line, but as the distance, distance h between the 2 points get closer and closer to 0, the line becomes closer and closer to the tangent line. So right now the difference is like 0.01. Almost 0. It's not exactly 0. You can't do exactly 0 because
Then it wouldn't touch.
because then there's no 2 points to draw the line, right? But as it approaches 0, it will approach the tangent line.
Yeah.
Does that make sense? It looks more and more like the tangent line. So this is a new concept. Yeah, still not the tangent line yet. And that's why what we do is, okay, so we're ready for this? Gradient at 1, 1 is actually, this expression, remember, this is the expression, right? So, and note that the bottom 1 plus h minus 1 is just h, okay? So the top is 1 plus h, everything squared minus 1, and then the bottom is just h. Make sense? Make sense so far? I'm just simplifying the bottom, all right? Now, see what happens. So we talk about like when h gets closer and closer to 0, the gradient of the line PQ, so this is the point P, that's the point Q. The gradient of PQ get closer and closer to the gradient of the tangent line.
When you like.
When the 2 points are closer to each other, right? So when the 2 points are apart, this is the point P. So even if I label this on point Q, and this is point P. See? The gradient of PQ right now is not like the tangent line at all, right? Not the gradient of not the instantaneous rate of change, or IROC. It's a short form, IROC, IROC. So use IROC. This is not the IROC, right? But when the H gets closer and closer, so when Q gets closer to P, right? It looks like the IROC, the instantaneous rate. Does it make sense, Sarah? Right now it looks like it, right? So, but then you can't actually have the h equals to 0 because look, if h is equals to 0, you get 1 plus 0 squared minus 1 divided by 0. You can't get that, right? So you can't substitute h equals to 0. What you can do, new concept, is called limit. You find the limit of what happens when h tends towards 0. That's new, okay? This thing is new. That's the calculus, the concept behind the idea of calculus. Right? The limit when h tends towards 0 of this expression of 1 plus h everything squared minus 1 over h. And note that this is like a function, yeah? So the notation is like lim h to 0 of something, right? It's like when you have sine of something and then cos of something. It's a function, yeah? It's not times into, it's a function of whatever is in the brackets. Okay?
So your limit is equal to like what your equation is to find like the gradient between the 2 points.
Well, okay, let me continue first, and maybe it will make more sense. So to find the limit, like as h tends towards 0, what does this one tend towards? What does it approach, right? So we'll continue that, but in order to do it, I need to expand that brackets over here. So that would be equals to, and this is actually the gradient, the actual instantaneous rate of change at 1, 1. Right? So we'll continue that. I'll show you guys the initial calculation. We'll do more exercises next week. So lim h equal to 0 of, expand that, will be 1 plus 2h plus h squared. Any question there?
No, minus, yeah.
Yeah, over h, right? No question there?
No.
Yeah, it's just a squared.
And so then you get 2h squared over h, right? Because then you get rid of the 1.
Yes, correct. So that will be, these two will cancel off. So that will be lim of h tend towards 0 of 2h plus h squared over h. And then you can take out h as a common factor. Alright, so h, and then you got 2 plus h over h, which is then you can cancel off the 2h here, because note that h is not 0, so you can technically divide by h. So that would be 2 plus h, and as h tends towards 0, as this value gets closer and closer to 0, that whole expression gets closer and closer to 2. That's right. So the final answer when you get rid of the lim is just 2. So what is this saying? This is saying that if we were to draw the tangent line at the point 1, 1, the gradient will be 2. Let's see if it's correct. So right now this line is not the tangent line, but I will actually do the tangent line. That will be 1 minus 1 equals 2 times x minus 1. That will be minus 2 plus 1 is minus 1. All right. So it will be 2x minus 1. See, that's a tangent line. And the gradient of that is 2.
How do you know it's... Oh, because it's when the tangent line intercepts with the x-axis as well? Is that your run?
No, hang on. So this line here is the tangent line, yeah? Because it only touches at one point. No matter how much you zoom it in, it only touches at the point P.
So how do you find the gradient of that line with that? Like, because obviously it's the...
How we found it?
Find the rise of it.
You...
Because if it's like rise over run, isn't that...
You can't find the rise over run for that tangent line.
But then how do you find the gradient?
How we find that gradient was what we just did over here. This is the fundamentals of calculus. This is the idea of how do we find the actual gradient of at a point, the actual instantaneous rate of change, the gradient of the tangent at that point is to use that thing there, is to consider. So that's why I'll recap a little bit, is to consider what happens when there are 2 points. Okay, you consider what happens when there are 2 points, right? And you start off with 2 points, right? And then you consider what happens when the 2 points get closer and closer together.
So how do you find then what's the point of having the other point there? Like, what's the point of this?
The Q point or the P?
Like both, because obviously the P is the initial point. That's where the tangent.
That's the one that you want to find a tangent for. Yes.
So what's the point of having the Q?
Having the Q is to define. So remember, the Q was to get the initial function, which is rise over run, which is this thing here, right?
Okay.
Right. Without the Q point, you can't get that part there, right? With this part, with the rise over run part, then you consider what happens when
H is getting...
when H gets closer to 0. So when the 2 points get closer to each other.
So you're not actually trying to find the difference of P and Q, you're trying to find what the gradient of P is.
Yes, we are trying to find the gradient at P, right? P is the main part we're interested in. Okay, so the gradient at P is, you can only do that by considering another point and then find out and think about what happens when the 2 points get closer and closer to each other. Okay, that's why I said this is the hardest concept to grasp in math methods. But if you get this, understanding the other concept will come a bit more naturally. Like, oh yeah, that's the instantaneous rate of change. Right? It's the instantaneous rate of change when at a certain point. And to do that, you need to start at 2 points first. Your teacher will attempt to teach this at school, or they may just give up and not attempt to teach this at school. But this is part of Unit 2 content. You will have to understand the fundamentals of calculus, essentially, like how derivatives are derived.
So what's your actual derivative? So your derivative is your gradient of.
The derivative, going back, gives you the gradient function. The
So
derivative
is this
gives
how we
you
work out the derivative. This is like.
one way. This is the original way of how people work out derivative. But you guys will learn a slightly easier way. But first, you gotta learn the meaning of derivatives. Okay. And again, this is we haven't done much about it, so we'll get back to this next week. Okay. So make sure, Blake, if you're listening, make sure you bring your 18A sheet for next week, and your laptop as well to show me what you've done for your assignment. Okay.